Next problem is a 100 megahertz uniform plane wave propagates in a lossless medium for which epsilon r is 5, mu r is 1. Then find attenuation constant alpha, phase constant beta, and wavelength lambda, phase velocity, and intrinsic impedance. So it's already given it as like a lossless medium. For a lossless medium, attenuation constant alpha equals to 0. So we know that the propagation constant gamma is equals to alpha plus j beta. Alpha is already 0 here because it is a lossless medium. So we have phase constant beta equals to omega into square root of mu into epsilon. In order to substitute the mu and epsilon values, this mu can be written as mu naught into mu r. Epsilon is nothing but epsilon naught into epsilon r. So omega is 2 pi f. Frequency already given 100 megahertz, 100 into 10 power 6. Mu naught is absolute permeability 4 pi into 10 power minus 7. Relative permeability is 1. Then absolute permittivity is 8.854 into 10 power minus 12 farads per meters. Relative permittivity is 5, already given. So by simplifying this calculation, phase constant beta is equals to 4.686 radians per meters. Next one is the wavelength. We have a fundamental relation. Phase constant beta equals to 2 pi by lambda. From this, lambda can be written as lambda equals to 2 pi by beta. Already we calculated beta here. The same value we can substitute here. Therefore, wavelength lambda equals to 1.34084 meters. So after calculating this wavelength, we can go for the calculation of phase velocity because it is the lossless medium or free space in which phase velocity is same as the propagation velocity or velocity of propagation. It is denoted by Vp. Therefore, the phase velocity Vp is equals to product of frequency into wavelength. Already frequency given 100 megahertz. Lambda we calculated it as 1.34084. So by simplifying it, it is 134.08 into 10 power 6 meters per second. Now they have asked us to calculate E by H ratio. It is nothing but eta, intrinsic impedance eta. This is equals to square root of mu by epsilon. So this mu and epsilon can be expanded in terms of relative and absolute values. So we know the values 4 pi into 10 power minus 7 into 1 here, and similarly absolute permittivity 8.854 into 10 power minus 12 farads per meters. Relative permittivity epsilon r equals to 5. By simplifying this, we'll be getting this, and further simplification will give us intrinsic impedance eta equals to 168.422 ohms, because here eta is nothing but it is the ratio between electric field intensity and magnetic field intensity. E by H is equals to in terms of ohms. The reason is it is in volts per meters and this is ampere per meter. Ampere per meter. So we'll be getting it as volts per ampere, that is nothing but resistance or impedance which is measured in ohms. Next problem is in a given medium electric field intensity E equals to 10 into cos of 2 pi into 10 power 70 minus beta x, and which has got two vectors like E per along y direction and along z direction. So from this, the magnitude of electric field is 10, and with comparing with the standard format, it is omega. Omega equals to 2 pi into 10 power 7 omega t. So and minus x is indicating that the direction of propagation, it is not a orientation, direction of propagation is along x-axis. So from the given expression and from the given values, mu equals to 50 into mu naught, and similarly permittivity is 2 into epsilon naught, and we have conductivity sigma equals to 0. We have to calculate the phase constant beta and H. So understanding the given problem, they have given electric field intensity and medium constants, and we need to calculate phase constant and magnetic field intensity. So by knowing the electric field intensity and intrinsic impedance, we can calculate the magnetic field. Beta is anyway, it is 2 pi by lambda. So from the given data or information, omega is equals to 2 pi into 10 power 7, and already given it as sigma equal, conductivity sigma equals to 0, therefore obviously it is going to become alpha equals to 0. Next one is mu is nothing but mu naught into mu r. It is given as 50 into mu naught. So from this, mu r is nothing but 50. This is clear. Next one is epsilon is equals to epsilon naught into epsilon r. It is given as 2 into epsilon naught. So from this epsilon r is relative permittivity is 2. This is also clear. Next one is we have to calculate the phase constant or phase shift constant. This phase shift constant beta is equals to omega into square root of mu epsilon. Omega already given 2 pi into 10 power minus 7, and mu and epsilon, if we can expand and by writing in terms of absolute values and all other, so this is the expression. By simplifying it and multiplying with 2 pi into 10 power minus 2 pi into 10 power 7, we'll be getting beta as 2.0958 into 2.0958 radians per meters. So this is phase constant beta. So from the given electric field expression here, we can see I already told you that it is minus x means, which is indicating the direction of propagation is along x-axis, and which has got two components. Just after multiplying with that, first part is along y direction, second part of electric field intensity is along z direction. So like this. E1, suppose if we can assume E bar as E1 plus E2, or E bar as E1 into AY cap plus E2 into AZ cap. E1 is along y direction, E2 is along z direction. The resultant of this would be the field direction. So we can take the magnitudes, similar magnitudes, because the same is there. So along y, along z. The important thing is the direction of propagation is, it is always along x direction. This we can see from this particular minus beta x. So we have to calculate the value of intrinsic impedance eta, because to calculate magnetic field intensity, E by H equals to eta ratio is there. So eta equals to square root of mu by epsilon. By substituting the values, the intrinsic impedance value is 1881.55 ohms. So we have now electric field E1 and E2 eta, so that from that we can calculate the magnetic field intensity. And before that, similar to our electric field, magnetic field can also be resolved into two components, H1 bar and H2 bar. This H1 is nothing but, because E by H equals to eta, or H equals to E by eta. So H1 bar is equals to E1 bar by eta. E1 is amplitude, that is 10. It is either it may be E1 or E2. Magnitude is 10. By eta we already calculated this. So by simplifying that, we'll be getting 5.314 milliamps per meters. Similarly, we'll be getting the same value H2 also. H2 equals to E2 by eta. E2 magnitude is 10. By that eta value, it is also 5.314 milliamps per meters. So we got now H1 and H2. Very important thing is, as this E1 is along y-axis. Suppose if you take like this, if we take like this, just a minute. And like this, we can see here, this is the direction of propagation. If it is x, this would become y, and this would become z. Already wave is propagating along x direction, so in this way. So which has got, one is z component, another one is y component horizontally. So based on that, in this we will discuss in terms of two different colors. It is very simple for us. Let us take, this is the direction of propagation, x-axis, and we have z, and we have y-axis like this. So E1, electric field, first component of electric field is along y-axis. So this is y. I am using for electric field, blue color I am using here. Let us say along y means it would be like this. It would be like this along y. The next one is the magnetic field. This is E1. E1 bar is along y direction, ay cap. Okay, then it's giving same color. Correct. Suppose if E1 is along y direction, it is already x is there, so H1 should be perpendicular to E1, means it is a vertical component like this. It should be a vertical component, means along y axis. So based on this, if E1 is along y direction, this H1 should be along z direction. So that is how we can calculate the direction of H1. E2 is along AZ. After AZ, because already direction of propagation is x, z to x, it is not z to x, x to z. X to z means actually x into y we should be there, so it will be in the negative y axis. So from these two, based on E1 direction of H1 is AZ, based on E2 AZ direction, as the direction of propagation is already x axis, x to z is not direct relation, so it is along minus ay cap. So H bar is equals to H1 bar plus H2 bar. Now we know the magnitude of H1 and H2 is same, 5.314 into 10 to the power of minus 3 ampere per meter or milliamperes per meters, and the wave expression is cos of 2 pi into 10 power 70 minus 2.0958 into x. This is along z and this is minus ay. So we can combine these two and finally we can write the magnetic field intensity as magnitude 5.314 and that expression, and directions are az minus ay. 10 power minus 3 means milliamps per meters. So in this way we can calculate the field expression. Next problem is a 300 megahertz plane wave propagates through water, for which conductivity sigma equals to 0, relative permeability mu r equals to 1, relative permittivity epsilon r is 78. Then find attenuation constant, phase constant, wavelength and intrinsic impedance. This is similar to our previous example of problem, as given medium is lossless, so water is also lossless. In this pure water it might be, they might have assumed. So beta is standard format, omega into square root of mu into epsilon. We can expand mu and mu naught. 2 pi f, frequency already given 300 megahertz. So by substituting mu naught value, mu r is 1, epsilon naught value and epsilon r is 78, and simplifying this we will be getting phase constant beta is equals to 55.487 radians per meters. This is how we can get the value of beta. Once if you know the beta, 2 pi by beta is wavelength lambda. So 2 pi by that 55.487 will give us lambda equals to 0.11323 meters. This is wavelength. Now we have to find the intrinsic impedance. Intrinsic impedance eta equals to square root of mu by epsilon by expanding mu and epsilon and substituting the values of relative permittivity and permeability and simplifying that equation. we are going to get it as 42.6559 ohms. So this is intrinsic impedance. So for the given problem, we calculated alpha 0, beta and wavelength lambda and intrinsic impedance. Next one is, this is very important problem. I'm saying that based on the previous question papers, how many times they asked this under UG level. So we have to concentrate more. A 6 gigahertz uniform plane wave is propagating through rexolite, a dielectric medium, with relative permittivity 2.53, and it is propagating in positive z direction. Propagating through the dielectric material with relative permittivity 2.53, propagating in positive z direction. Plus a z cap means it is a positive z direction. The electric field at z equals to 0 means boundary condition or boundary surface is 100 at an angle 0 degrees volts per meters. Then calculate phase velocity, phase constant at z equals to 4 centimeters and calculate the total attenuation in decibels over a distance of 6 wavelengths with the last tangent tan delta equals to 0.0005. So this is the given problem. Now we have to go for the calculations of this. Phase velocity, a standard format here, Vp equals to square root of mu into epsilon. We have to substitute the values of mu. Mu is mu naught into mu r, standard representation. Epsilon is epsilon naught into epsilon r. The relative permittivity and permeability values. Relative permittivity they have given as 2.53 for rexonite dielectric material, but relative permeability they have not mentioned. If they have not mentioned, by default we have to assume it as relative permeability equals to 1. So which will give us like these values, and by simplifying this, the phase velocity Vp equals to 1.886 into 10 power 8 meters per second. So after finding this phase velocity, we can go for the calculation of wavelength lambda. We know that lambda equals to velocity of EM energy to the frequency. Velocity already we calculated, phase velocity, and frequency is 6 gigahertz. This is giga means 10 power 9. So by substituting and simplifying this, lambda is equals to wavelength lambda equals to 0.0311 meters. After finding wavelength, we can calculate phase constant beta. So beta equals to 2 pi by lambda. We will be getting this value as 202.03 radians per meters. Already given last tangent tan delta, its relation is sigma by omega epsilon. Sigma is conductivity and this is radial frequency, and epsilon is permittivity. So from this we can write sigma equals to, just you need to multiply with this, omega epsilon into tan delta. Omega is 2 pi f, epsilon can be expanded as epsilon naught into epsilon r, and tan delta here. So tan delta already given. So frequency we know 6 gigahertz, 2 pi f, and epsilon naught 8.854 into 10 power minus 12 farads per meters. Relative permittivity they have given 2.53, last tangent already given. By simplifying this, we'll be getting the value like conductivity sigma equals to 4.222 into 10 power minus 4 moles per meters. Then for a practical dielectric, we know that the propagation constant gamma equals to, this is good dielectric. We have that relation we already derived in that medium properties based on the given mediums. This is actually gamma. Gamma equals to alpha plus j beta. By simplifying it, we are going to get for practical dielectric or under good dielectric conditions like sigma by epsilon, sigma by 2 into square root of mu by epsilon plus j omega into square root of mu epsilon. This is attenuation constant alpha, and the second part is beta. So by taking this attenuation constant alpha equals to sigma by 2 to square root of mu by epsilon, already we calculated this. That is the reason why we calculated the conductivity sigma. Mu and epsilon we already know, it is Nepers per meters, and phase constant beta is omega into square root of mu epsilon is radians per meters. Now attenuation constant alpha is equals to, from that formula we substituted here whatever the value we got or calculated, that conductivity by 2 into square root of mu by epsilon values. If we can substitute here the simplified equation, or the value is alpha equals to 0.05003 Nepers per meters. This is how we can calculate the attenuation constant. Now actually they asked us to calculate this attenuation constant in decibels, or attenuation in decibels. Now first we have to go for the electric field intensity at Z equals to 4 centimeters. We have a standard representation of that. Modulus of that is E naught into e power minus alpha Z. Alpha is attenuation, Z is the direction of propagation. It is given in centimeters, 4 centimeters. All the parameters are in terms of meters, so we have to write it in terms of meters. 4 into 10 power minus 2. Alpha already we calculated 0.05003. So e power minus 100 into e to the power minus 0.00200012. By simplifying it is around, we are going to get 100 volts per meter. So what is this? This is electric field intensity along the direction of propagation at Z equals to 4 centimeters. So by taking the magnitude, we'll be getting 100 volts per meters. Now here the phase angle beta, phase angle, it's not a phase constant, we have to understand. Phase constant is beta, its dimension is radians per meters. So phase angle we can write it in terms of multiplying with the distance. So minus beta into Z, it is called phase angle. So beta already there, and Z is 4 centimeters, we have to convert it into meters. So by substituting these two values, we are going to get it as phase angle minus beta Z equals to minus 8.0812 radians. Similarly, attenuation, it is not attenuation constant. Attenuation at Z equals to 6 wavelengths distance. So e power minus alpha Z at Z equals to e power minus alpha Z at Z equals to 6 lambda. So we are substituting alpha value, attenuation constant, 6 into wavelength already calculated. It is e power minus 0.009335, and the attenuation in Nepers is that 0.009335 Nepers. From Nepers to decibels we can convert by multiplying with 8.686. Therefore attenuation constant in decibels is that value, Napier value into 8.686. It is 0.081089 decibels. This is how we can calculate the attenuation in decibels. So these are the important problems. You can practice it, and similar kind of problems with the different small numerical value changes in those parameters or given conditions. By practicing like this, you can be in a position to solve any problem given in this. We'll meet in the next class. Thank you.